Hey everyone, Mr. H here, going to do some 3.4, last section in chapter 3. It's on counting techniques, namely permutations and combinations. So we've seen in probability that counting up the total number of outcomes is rather important. And when problems get more complicated, these two techniques come into play. So let's look at permutations. The key is that it's an ordered arrangement of objects. Keyword there being ordered. So order matters. Right? I would even make a note of that. Order matters. And we'll see that when we do some examples. There is a formula for the number of different permutations of n objects. It's n factorial. If you haven't seen factorials before, here's a little example. I can squeeze it in here. For example, let's do 4 factorial. That's the way you calculate that is 4 times 3 times 2 times 1. So you start with the number, decrease it by 1 each time until you get down to 1, and then multiply them all together for the answer. So 4 factorial would equal 24. Okay, so let's look at some examples where we would have to use permutations. So suppose we have 3 friends and they're going to take a series of selfies. They want to have every possible arrangement. So how many selfies do they have to take? And they're lining up shoulder to shoulder. One that I can think of right off the bat is ABC, Alfred, Betty, Carlos, right? If you want to take a moment, hit pause and see if you can list them all. Feel free to do so. Otherwise, I'm just going to continue here. The next one I think of is leave Alfred where he is and switch around Carlos and Betty, right? And this is now all the permutations where Alfred is on the left. Now, we can do Betty on the left. So BAC, or B, switch them around, CA. That's all the combinations with Betty on the left. Finally, we need Carlos on the left. That would be a CAB, CBA. And those are the 6 permutations. Right? Notice here, order matters. It's always the same 3 people, but switching them around and you get a new permutation. And that's the key. So the answer here is 6 because they had 6 total selfies. That's every possible arrangement. Notice here how that formula also would work. Instead of listing them all, we could have just calculated 3 factorial. There are 3 people. How many permutations? 3 times 2 times 1, 6. Okay. Number 2, they run into Drake. Drake's a cool guy. He wants to take selfies with them. Now, how many total possible arrangements are there? It's going to be a little bit more. Now we got 4 people, right? I mean, we can do the A, B, C, D, Drake on the right. Right? Or we can now move Drake around and switch people around. Okay, we're going to have a lot. I'm not really interested in listing them all. Right? Not really the point. The point is how many total are there? So at this point, I'd probably start using my formula, right? This is going to be 4 people, 4 factorial. 4 times 3 times 2 times 1. That's 24 selfies. Okay. Now, why do it that way? I mean, where does this formula even come from? Like, why is that? Well, if you think about these 4 numbers as the 4 locations of where people will be standing in the photograph, and then just imagine them as just being blank pieces of tape. Okay, now in this spot right here, I'm going to put somebody. When I first begin, I have 4 people to choose from. So that's where that 4 comes from. It's how many choices I have for that spot. So I pick one, and then now I move to my next spot. Now, since I've put somebody here, I only have 3 choices for this person, right? And then I continue in that matter. Once those 2 are fixed, now for this spot here, I only got 2 people. And then finally for that spot there, there's only 1 person left. Okay, so that's where the formula comes from. That's the intuitive approach. You could just blindly use the formula, or you can do why the formula exists and count it out that way. Okay, so now we can do some extreme problems. Now they run into Pearl Jam. That's my favorite band, by the way. There are 5 members. So now we got a total of 9 people. Okay, So I don't want to list them all. That's going to be a lot. I'm just going to do 9 factorial, right? 9 choices for the first spot, 8 for the second, 7 for blah, 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 all the way down until I get to my last spot. Okay. Now this, when it starts to get kind of long, well, there are calculators, and yours probably does it, that have a factorial button. You just got to know where to look for it. Everybody has different calculators. You might have the TI-84 or the TI-30 or something else. But if you have a minimum scientific calculator, you most likely have a factorial button. To learn your calculator, here's my advice. I would just Google. I would Google factorials for a TI-84 video. And then a little 2-minute YouTube video will certainly come up. Okay. That's what I do with my calculators. If I can't find something, I don't use a user manual. I just Google it and watch a little YouTube video. So factorials for a TI-30 calculator. Boom, we'll get something. Okay. Okay, so anyway, if I did this calculation, I could just do it that way or find my factorial button, however you want to do it, but you should end up with 34,650 selfies. Okay, that's a lot. That's not even true. So if you calculate it, then you should get a lot, 362,880 selfies. Okay, gonna run out of room on your phone on that one. All right, a little bit of a different question now. The next one, they decide that having 9 people in the photograph is too many. Duh. So instead, they're just going to take 4 people at a time. Okay, so we still have 9 people to choose from, and we're going to take 4 at a time. All right, so think about the 4 positions and how we can fill them in with people. If I fill this first one in, I have 9 people to choose from. Once I fix that person, then I have 8 for the next spot. Once I fix that one, the first 2 are fixed. I only got 7 people left. And then finally 3 are fixed. So only 6 people are left. Multiply all those together and you'll have your answer. So this is 3,024 selfies. Okay, so that's the intuitive approach. And there's a notation for it. This is choosing from 9 people, 4 at a time. That's 9P4. Okay, so 9P4 is calculated like that. All right, start with 9 and go all the way down until you have 4 numbers. Okay, and there's a little formula for it. Here it is. Right, so you could just use this formula. Right, let's see how that works. So if I just kind of try that previous problem, but you just sticking to this formula. So 9P4, it says to do at the top, the n factorial, which is 9 factorial. And then the bottom, it says do 9 minus 4 factorial. Okay, so that's what the formula, how the generalized formula looks like. This is when you're doing a permutation, but you have more objects than you're choosing in your permutation, right? So we have 9 to start with, but we only want 4 at a time. The previous problems, these first 3, we had the same number of objects as how many we're choosing, right? We had 3, we're choosing 3. Had 4, we're choosing 4. Had 9, we're choosing 9. Here we have 9, we're choosing only 4. So that's why the formula is changing here. Okay, so if I wrote this out, 9, 8, 7, 6, 5, 4, 3, 2, 1. This one, 9 minus 4 is 5. That's 5 factorial. 5, 4, 3, 2, 1. All right? And then if I did some canceling, which you should always cancel using red. I don't know why, it just looks good, right? You'd end up with what we did here, right? So the formula does work. I mean, my suggestion is either just kind of do it the way we originally did it, or you have this function in your calculator. So you have a factorial function. You also have a permutation function in your calculator. Again, Google it. I would just Google permutations for the TI-84 video. Somebody on YouTube has it out there. 2 minutes, you'll figure it out. Okay. Permutations for the TI-30 video, something like that. Okay, let's try some other examples then. Find the number of ways of forming a 4-digit code in which no digit is repeated. So in codes, order matters, right? Like 1, 2, 3, 4 is a different code than 4, 3, 2, 1. So when order matters, it's a permutation, and no digit is repeated. If digits were repeated, we kind of already did that back in 3.1. Okay, so let's try this out. I like to think about my 4 spots and then start filling them in. How many choices do I have for each spot? So my first digit, remember digits are 0 through 9. There's 10 possible digits to choose from. So I have 10 choices for this one. Once I fix that digit, I can't use it again. So I only have 9 choices for that one, 8 for that one, 7 for that one, right? Or in other words, this is 10P4. Choosing from 10 digits, I want a 4-digit code, right? So now you can either just multiply those 3 together or use your calculator function of 10P4. Oh, real quick, another idea. Let me do a quick share of my desktop. Calculator.net, if you just do calculator.net permutations and combinations, they have a calculator for that too, right? So this was 10P4, right? And calculate 5040, and we'll get to combinations in a minute. So you can use that as well. That one's pretty easy since you're doing everything on your computer anyway. Got your permutations and combinations calculator ready to go. Okay, so that's calculator.net permutations and combinations calculator. Give it a try. All right, back to the handout. Okay, let's go and try that one about the racing. There's 43 race cars, and how many ways can the cars finish first, second, and third? 43 to choose from. We are choosing 3, first, second, and third. P, because order matters. Coming first or you come in second, that's a different permutation. Okay, so do that on your permutation calculator, or your handheld calculator, or just do 43 times 42 times 41. It's probably what I'll just do it real quick. And we get 74,046. Okay, all right. We got one more type of problem here, but I'm running a little bit out of time. I'll do another quick video on distinguishable permutations on the next handout. Okay, hope all is well. Talk to you later.